Dear students, today we will see the very important area on virtual memory. What is exactly virtual memory means and why we need to understand this particular form of a technique. Now, to understand this particular virtual memory, let us take one simple example. Assume that you are having a CPU which is of 32-bit program address space, and let us put it as 32-bit program address space. Of 4 GB, and there is a RAM inside that computer which is a 30-bit RAM, and its address space of 1 GB. Now you just see, this is 4 GB and this is 1 GB. Assume that this address space is distributed, and let us take 0, 1, 2, 3. Now if you try to map 0 to 0 address, 1 address, let us take that this is 0, 1, 2 occupies this one. If you map this address, what happens to this one? Where it will go? If these situations arises, that means you are having in the CPU program address, you have stored a particular program, you have written one algorithm, and you have written based on that you have written a computer program, and you have saved it in a space, and from in that space, let us take that you have saved it in a secondary memory or in a particular drive. From there the RAM is calling one after another, and if suppose this is one particular programs where the address occupies the space of a 0 to 3, 0, 1, 2, 3, and when it is called to the RAM, it is only 0, 1, 2. What happened to the third? So if this situation comes, then we say that what happens? Then a crash will occur, because the third bit address or a program address is not being processed by the RAM. And if this completely 0, 1, 2, 3 and 0, 1, 2, 3 need to concurrently process, and if this particular process is not taken place, automatically that particular program is going to get crash. So a virtual memory take place program address into the RAM through what we use a word like a mapping. Mapping means what? As here I have shown directly, that is 0 bit has 0 address has taken to the RAM, 1 address, 2 address, but third address was not taken place. But if this particular mapping is, if it is done, what is going to happen is this one. The third will come to mapping same way, 2 will come to the mapping same way, 1 will come to the mapping, 0 will also come to the mapping. Through this mapping only it will go to the RAM. Second is gone, third is also, no, 0 has gone, 1 has gone, and 2 has gone. In the case of a third, if that situation comes, this will go to where? It will go to the, say, a hard disk, secondary memory. It will go to the hard disk. So in the case of a virtual memory, mapping, I can put it as a mapping gives flexibility to utilize RAM effectively. You just think like this one with a very simple examples. You are sharing a book. You are sharing a book with say, let us take a single book with the 3 friends. So if you want to share this book with the 3 friends, what you can do, you take this book for reading, and after a predefined times you interrupt yourself and you take another book and you start reading, and you allow this person to read, and let us think that this person is also reading this book, and after that this third person's needed this book, you give it to here and give it to this third person and take this book and you use it. So this entire thing is a mapping process. So this is basically used to solve the problem if virtual memory is used wherever not enough memory is available, enough memory availability exists. This particular virtual memory is being used. So in the case of a virtualization, you will try to see that you are having a program load address, program you are loading with the address 0, program loading with the address 1, program loading with the address 2, like that, program loading with the address n. All these things has to pass through a mapping, and thereby the depending upon the size of the RAM it will be taken, and the remaining, you can put it as remaining, it will be determined by the disk availability in the particular systems. And this virtual memory is always effective in a operating systems. Each program has its own mapping, and mapping let us put one program data to wherever the particular task has to be carried out through the RAM. So every process will be processed through the RAM for a effective and a fast operating systems. Hence the performance of the systems will improve, and the CPU will be able to give a maximum efficiency. CPU will be producing efficiency wise better, and CPU utilizations will also improve because the systems will not having any crash. Hence the virtual memory is being oftenly used in the operating systems, and that's why the system performance improves. Thank you.